Good day, everyone. You are welcome to Planar Stereo Collect class. And the topic that we have here is differential equation. Now, obtain the differential equation associated with a primitive y equals to as squared plus bs plus c. So, any relation that actually involves essential arbitrary constants, they are referred to as the primitive. So, this is a primitive because here we have three essential arbitrary constants, and we denote them with capital letters. That's A, B, C. And again, the primitive is usually referred to as the general solution of the differential equation, and it is from the primitive that we obtain the differential equation. So now let's go to the solution. So here we have the primitive, which is y equals to as squared plus bx plus c. So this is the primitive. So here we have the primitive here. And if you are given a primitive and you have to obtain the differential equation, the number of constants that we have the essential arbitrary constant, the number of constants will tell us the number of times that we will differentiate it. So now there are three constants over here. That means we need to obtain the derivative three times. We need to differentiate three times. So now the first time I need to have the y over the x, or we can also write this one as y prime. So this one is equals to, by the time we differentiate ax squared, that will give us 2ax plus, when you differentiate bx, that will give us b, and when you differentiate c, that will give us 0, because this c is a constant and there is one variable x at the back. So now differentiating the second time, that will be the square y over the x squared, or we can also write it as y prime prime is equals to, we differentiate this one the second time, that will give us 2a. Now differentiating b, that will give us 0. So now then we differentiate the third time. So don't forget that there are three essential arbitrary constants here. That means we need to differentiate three times before we can obtain the differential equation associated with this primitive. Now differentiating the third time, that's the cube y over the x cube. So we can also rewrite this one as y prime prime is equals to, we'll go back to the second derivative where we have y prime prime, or the square y over the x square, where we have 2a. We'll differentiate this 2a the second time. That will give us 0, because here in this case there is no x at the back, so 2 is a constant, also a is a constant, that will give us 0. So therefore the differential equation associated with this primitive is, that's the cube y over the x cube. So that is the final solution. This is the differential equation associated with the primitive. Kindly like this video and share and follow for more.